The extension for 1.6 is all about adding and subtracting fractions, and you'll see in a couple of examples why it fits so well when we were doing least common multiples of in 1.6. So just a quick reminder though, that when you are adding and subtracting fractions, you must make sure that they have common denominators before you do any other kind of adding or subtracting work with them. And there are going to be several ways to write equivalent, which means equal fractions with common denominators. For example 1, we're going to try to just add fractions using a common denominator. So for this first one, we're going to find 5/8 plus 1/6. So if we were going to do that in this case, we could use the product of the denominators. So we could multiply 8 times 6, and that would give us 48. So then we would use that as our common denominator. And remember, when you're changing fractions, whatever you do to one part of the fraction, you have to do to the other. So in this case up here, 5/8, in order to make 8 into 48, you would have to multiply that by 6, and if you do that to the bottom of the fraction, then you're going to have to do that to the top. And so in this case, 6 times 5 would give you 30, so that would be your new numerator for that fraction. And then in this case, 1/6, you would multiply 6 by 8 to get you 48. So you would do that on the bottom and on the top, and 1 times 8 would give you 8. So the new numerator for this fraction, oops, I guess it doesn't matter what color it is, would be 8. And then once you have them in common denominators, then you just add your numerators. So in this case, 30 plus 8 will give you 38, and then your 48s should stay the same because you should never add your denominators together. So 38 48ths is the fraction, and then we will talk about putting that in simplest form too. Since 38 and 48 are both even numbers, one way to help get this down into simplest form is to just divide by 2 in this case. And 38 divided by 2 is going to give us 19, and 48 divided by 2 would give us 24. And then we always have to check and see if we could make either of those lower. Could they be divided by a common factor to go any lower? And since 19 is prime anyway, the only things it can be divided by are 1 and 19, and 1 is the only one of those that goes into 24. So that's as low as we can get it to go. So our final answer for 5/8 plus 1/6 would be 19/24. So one vocabulary word that you're going to hear come up a lot when you start talking about fractions is least common denominator, or LCD. And this is the connection to the work you were doing in the 1.6 video and work recently. So the least common denominator of two or more fractions is actually going to be the least common multiple of whatever those denominators are. And we're going to practice that in example 2. Alright, for example 2, we're going to be adding fractions using the least common denominator, and we actually are using that same exact problem that we did in example 1, 5/8 plus 1/6, but we're going to, instead of just multiplying our denominators together, we're going to see if we can find the least common denominator. And we said one way to do that is to find the least common multiple. And again, in chapter 1.6, we saw there were a couple of ways to find the least common multiple, and one way was to use lists. So we're going to go ahead and make lists for the multiples of 8 and 6. And if I start putting my multiples list together, it starts with 8, because 8 times 1 would be 8, and then it goes to 16 and 24, and I can keep going on all day long, but I'm going to start with that because I think I recognize something that'll be helpful here. And so then I'm going to list my multiples of 6, and I've got 6, 12, 18, 24, and again, been working with these numbers for a while, so I see right away that they have 24 in common, and that's the smallest number that they have in common, so we would call that our least common multiple. And now we're going to go ahead and use that as our least common denominator too. So here we go. Since we found the least common multiple of those two numbers to be 24, then we're going to rewrite our two fractions with 24 at the bottom. And this time, instead of multiplying our denominators together, 8 times 6, we're going to figure out what we'd multiply 8 by to get to 24. And I know that's 3, so whatever I do to one of those fractions, parts of the fractions, then I'm going to do that to the other. So 3 times 5 is 15, and I'm going to write that down here. And then the 6, I'm going to actually have to multiply that by 4 to equal 24. And again, whatever I do to one part of the fraction, I will do to the other, and 1 times 4 is 4. So now I have two equivalent fractions with the least common denominator of 24. And the reason this method is really helpful is because once you go through and you add your numerators together, 15 plus 4 is 19, and we keep the 24 as the denominator, you notice that we didn't have to do any simplifying. So if you can find the least common denominator, it will make your job a lot easier in that you don't usually have to simplify. And just a quick reminder before we move on to the next example that you could also find the least common multiple by using the prime factorization method. And remember, you can go back to the 1.6 video and notes to kind of remind yourself how to do that if that's something you were feeling more comfortable with. In example 3, we're going to be subtracting mixed numbers, and these same rules that we've been talking about in this whole video apply to both adding and subtracting fractions and adding and subtracting mixed numbers. You use the same methods. But something that you're going to want to remember when you're working with mixed numbers, and remember a mixed number would be a combination of a whole number and a fraction, so this would be considered a mixed number because it's both whole number and fraction. And when we're working with these, then it's sometimes, or usually actually, it's a very good idea to write them as improper fractions first. So just a quick refresher, when we're turning a mixed number into an improper fraction, remember that we take your denominator down here and we multiply that by your whole number. So in this case, 4 times 4 is 16, and then we add that to the numerator, which is 3, so 16 plus 3 would give us 19, and then we keep our denominator the same. So in this case, we have 19 fourths, and then over here, if you were going to do 2 and 3 tenths, then again you would multiply your denominator by your whole number, so 10 times 2 is 20, and then add your numerator, which is 23. So this, as an improper fraction, would be 23 tenths. And they call it an improper fraction because your numerator is bigger than your denominator, and that doesn't normally happen in fractions. And then we go through and we think about how to put those into common denominators. So the book shows, again, when you're going to do the common denominators, it reminds you the two methods. You can multiply your two denominators together, but then you're probably going to have to simplify. So in this video, I'm just going to keep focusing on finding the least common multiple and hopefully reducing the amount of simplifying that we've got to do. So I'm looking for the least common multiple of 4, and the multiples are 4, 8, 12, 16, 20, and I'm going to stop there because I can tell that 10 is going to go into there. And so multiples of 10 would be 10 and 20, and I see that they have this one in common, so I can go ahead and use 20 as my new denominator here for each of my fractions. And when I'm trying to convert these fractions into 20ths, like I want for down here, then I look at the 4 here, and I figure out what I would have to multiply that by to get it to 20, and I would have to multiply it by 5, and so I'll do that on the top of the fraction too. And you would want to do some side math in this case, but you could figure out that 19 times 5 would give you 95, so that's going to be your new numerator. And then in this fraction over here, I would take 10 and multiply it by 2. And if I multiply the denominator by 2, then I also have to multiply the numerator by 2. So again, side math would be a good one on this one. And 23 times 2 would give me 46. And since I have them in common denominators now, all I have to do is subtract the 46 from the 95. And I would, again, do that in side math. And then I would figure out that that's going to leave me with 49 over 20. And I can technically stop there, but when we have an improper fraction where our numerator is bigger than our denominator, we try to always turn that back into a mixed number, and we figure out how many times 20 can go into 49, and it can go into it 2 whole times without going over, because 2 times 20 is 40, and that would leave me with 9 left over as my new numerator, and I would keep my denominator as 20, so 2 and 9/20 would be my final answer here. And again, this should be just a refresher from last year, but this video is available if you want to go back, or if you need to ask questions about how to turn things from improper fractions to mixed numbers and vice versa, just let me know. To do a little bit of practice on this, you're going to do from Big Green, page 43, and you're going to do 1 through 15 odds only. And one thing you might notice is that for problems 5 and 7, they ask you to compare the two fractions using less than, greater than, or equal to. And there wasn't technically an example like that in this extension video, but that's just going back to the skills that you had from last year, comparing fractions. And remember that you do have to have common denominators before you can compare your fractions, and that's what we were practicing in this section. So once you get your fractions in the common denominators, then you would be able to look at the numerators and see if one fraction is greater than, less than, or equal to the other one. Other than that, it's all stuff that we did in this video.